Hello everyone. Today in this video we'll be doing the naming of alkenes. The rules remain the same, general rules that you have to look out for the longest carbon chain, etc. Now the only difference is that in alkenes there is the functional group of a double carbon-carbon bond. So the double carbon-carbon bond must get the smallest number, and that is what we have written on top, right? Now let's look at the first example. Over here we could number it from the left and the right? But if you notice one thing, the double carbon-carbon bond must have the smallest number, so it only gets the smallest number when we number from the right hand side. So the name of this compound would be but1ene. So let's notice this a little bit. Why is the 1 here? The 1 is here because the double carbon-carbon bond starts from the first carbon. The but is here because it is a 4-carbon alkene, and the ene is here because it is an alkene, and that is the suffix for it. All alkenes must end with an ene. So the 1 comes in the middle because this is the way that we write it. Okay, this is the tradition. Now let's look at the second one. If you count it from either side, the carbon atom, the double carbon-carbon bond will get the same number. The double carbon bond is on the second carbon. So the name of this compound is but2ene. Why is the 2 there? Because the double carbon-carbon bond is on the second carbon atom now. And the but and ene are there because there are 4 carbons and it is an alkene. Now we should number this from the right hand side so that the double carbon-carbon bond gets the smallest number. The name of this compound should be pent2ene. Why is the 2 there? Simply because it's on the second carbon. Pent because it is 5 carbons in the longest chain, and ene because it is an alkene. Now, what if you have branched alkenes? Simply enough, the rules remain the same. You have to look for the longest carbon chain, and so that the double carbon-carbon bond gets the smallest number. So this is the longest carbon chain, right? So we can name this, actually no, it is not the longest carbon chain, because if you number this from this side, and if you number it from this side, the branch would have a number of 2. It would have a smaller number from this side, and the carbon double bond would also be on 2. But if we do it from the right hand side, the carbon double bond would be on 2, which is the same, but the branch would be on 3. So you have to notice these tiny details. So it would be better to remain on the safe side and count from both sides and see which one is better. So we'll be going with the left hand side. So the name of this compound should be 2-methyl-but2ene. Why exactly? 2-methyl because the second carbon has a methyl group, but because there are 4 carbons in the longest chain, 2 because the second carbon has the carbon-carbon double bond, and ene because it is an alkene. So this is how we will do the naming. It's quite similar in the previous videos also. So just with practice you will get better. Now these are another way in which we can make alkenes structure, and usually this is related to isomerism or cis-trans isomerism, but we won't be talking about that right now because that is not our topic of discussion at the moment. Now simply look for the longest carbon chain in this also. We can start counting like this diagonally, right? And you would see that this is the longest carbon chain. Now we can see that there is a branch over here, and that is it, right? So there is a branch on the second carbon, and there is also the double bond on the second carbon. So the name of this compound would be again 2-methyl-but2ene, and you can simply see why exactly. Now let's name this compound. You would see that this is the numbering, and these two are the branches, right? So let's name it. The branches are on the second and third carbon atoms, and the double bond is on the second carbon atom. So the name of this compound would be 2,3 methyl bute 2ene. Simply 2,3 methyl because we have two methyl groups, and butene because the alkene group, the double carbon-carbon bond is on the second carbon atom, and it is an alkene with 4 carbons in the longest chain. Now what about this one, the last one? Now in this we can count from here, right? So 1, 2, 3, 4, 5, 6 carbons in the longest carbon chain. Now let's name this. First of all, let's look at the substituents. Okay, now the name would be 6-chloro 2,3 dimethyl hex 2ene. Now this is quite long of a name, so let's understand why exactly. 6-chloro because the chlorine substituent is on the 6th carbon atom, 2,3 dimethyl because there are two methyl groups on the second and third carbon atoms, and hex 2ene because the second carbon atom has the carbon-carbon double bond, and hex because the longest carbon chain is 6 carbons and it is an alkene compound, so therefore an ene is there. Now why is the chloro before the methyl? Simply because C comes before M in the alphabet. Now these are non-cyclical compounds. What if we have cyclical alkenes? What are their names like? Now this alkene is simply just a 6 carbon alkene, right? So, and the carbon double bond is on the first carbon, so the name would simply be cyclohexene, right? But what if you have two alkene groups? You would have to number it in such a way that the alkene double bonds get the smallest numbers. So I would number it like this. For instance, if I number it like this, I'll get the double bond on the first carbon and the fourth carbon, right? So now let's name this. It would be 1, 4 cyclohexadiene. Why is the diene over there? The diene is over there. The di means two alkene groups, and the cyclo is there because it is a cyclical compound, and the 1, 4 is there because the first carbon and the fourth carbon have the double bonds in them. So you do need to know how to name cyclical compounds also. Now what about a cyclical alkene with halogen substituents also? Let's learn this now. Now the numbering of this is something that you need to do by trial and error. If I number this like this, right, you will see that sure, the double bonds get 1 and 4, but the halogen substituents are getting 6. That is a very large number. So we will have to number this in another way now. Let's try numbering it like this, in a way to keep the 1 and 4 of the carbon double bonds intact, but to give the halogen groups also a small number. So now we have 3 over there. So now let's name this 3,3 dibromo cyclohexadiene 1,4 diene. Now why exactly is this the name? Let's look at it. 3,3 dibromo because the third carbon atom has two bromine substituents on it. Why the cyclo? Because it is a cyclical compound. Why hexa? Because there are 6 carbons in the ring. Why 1,4-diene? Because there are 2 alkene groups and they are on 1 and 4 of the carbon atoms in the long chain. So simply that is why this is the name. And this is it for naming of alkenes, and this is the end of this video. Thank you.